Good morning, children. Now we are here to discuss the question of exercise 10.1. The first question was that how many tangents can a circle have? As I have discussed earlier, that if we have to draw the tangents on a given circle from a given point, then we can draw only one tangent. But here the question is that how many tangents can a circle have? It means that the number of tangents which can be drawn on a circle. So, in that case, we are having every point on a circle, we can draw a tangent. Since there are infinite number of points on a circle, so the number of tangents also drawn will be infinite. So, if the question is that how many tangents can a circle have, we will answer that since there are infinite number of points on a circle, so infinite number of tangents can be drawn on a circle. Now question number 2 is having the fill in the blanks. The first one is that a tangent to a circle intersects it in dash points. Here you have to fill up the blanks. As we know that tangents to a circle touches at only one point, so here we will answer our 1 point only. The second fill in the blanks statement was a line intersecting a circle in 2 points is called what? As we know from the definitions of secant, that secant is a line which intersects the circle at 2 points. So the answer for the second one is secant. A circle can have dash parallel tangents at the most. So a circle can have 2 parallel tangents. If we are having a circle and if we draw a tangent over here, then over here we can have only 2 tangents which are parallel to each other. So we cannot have more than 2 tangents which are parallel to each other. So the answer of this one, a circle can have only 2 tangent parallels at the most. The last one, that what is the common point of a tangent to a circle and the circle is called, as we have discussed earlier also, that tangent touches the circle at point of contact. The point at which the circle touches is called point of contact. Here this line is touching the circle at this point, so it will be called point of contact. Now, in question number 3, it is a multiple choice question in which you have to answer that what will be the value of PQ. Since there is a point Q lying outside the circle and it touches the circle at point P with line segment PQ. Since the radius is given 5 centimeter, so and this length OQ is given 12 centimeter, we have to find out the value of PQ. As we know that tangent and radius are perpendicular to each other at point of contact. Here P is the point of contact for this tangent QP to this circle. So we will have a right angle triangle over here. Right triangle POQ, in which OP is known to us, that is of 5 centimeter, because radius is OP and the value of OP is given to us 5 centimeter. And here OQ, point Q is at a distance of 12 centimeter from the center. So the hypotenuse is 12 centimeter. We have to find out PQ. Now we will use Pythagoras theorem to find out PQ. PQ will be equal to the under root OQ square minus OP square. We will put up the value which are known to us. That is the value of OQ is 12. So it is 12 square. The value of OP is 5. So it is 5 square. Now 12 square will give us 144. 5 square will give us 25. So the difference of these two will give us under root 119. And the option will be D. Now here in question number 4. In this question number 4, we have to draw line and then we have to draw 2 more lines parallel to this given line out of which one will be tangent and other will be secant. Now, as we know that in standard 9 also, how to draw a line parallel to a given line. So using that property, we will draw a line P first inside the circle. This is the line inside the circle, and then by using the property, by taking set squares, we can draw a line parallel to line P at some distance, which will be a secant to the given line, given circle, and at some distance we will draw another line parallel to this line P, which touches the circle at a point A, which will be a tangent. We will draw a line parallel to a given line using set squares. But if you are having problem or having some trouble to use set squares, or if you have forgotten to use the set squares to draw the parallel lines, then here I have given you another method. In this one, you have to draw a circle over here with any given center, and then you will draw a diameter PQ by yourself. And in this diameter, we will take the points in between the circle, 2 points R and S. Now, it is a very simple one. We know how to draw the perpendiculars on a given line. Either using set squares or using compass, you can draw a perpendicular line at point P, at point R, and at point S. You can use either of it. Here I have used set squares, but if you want to use compass, you can use compass also to find the perpendicular lines over here. Here, line P is perpendicular to diameter PQ, line R is perpendicular to diameter PQ at R, and line S is also perpendicular to diameter PQ at S. Now what do we see that? We know by the property that lines perpendicular to the same line are parallel to each other. It means that this line P, line R, and line S all are perpendicular to PQ. Thus we can say that all are parallel to each other. Thus we are having our solution that tangent and secant are line P and R, and both are parallel to a given line S of the circle. Thus in this way you can also have your solutions. So you will now practice all the questions again to get command, and we will start our next exercise in my next video. Okay, good day.